Hello, I'm Robert, and helping people are scared of many things by fact-checking the stories that you read on the internet. And this is the one that you get so many people saying that human beings are going to go extinct because of climate change, or that civilization is going to collapse, and all sorts of things like that. The IPCC do not say this. So I'm just going to talk through the very easy, obvious things in this video. So first of all, how do human beings go extinct? If someone says this to you, ask yourself, what does the last human die of? Because if people go extinct, there has to be something they die of. And if you look at the projections from climate change, then by the year 2100, a lot of people worry they're going to die of heat. But look, this is Greenland, the year 2100, covered in ice. And this is the very worst possible scenario, which is now impossible, of increasing, burning practically nothing but coal by the year 2100, because it's the very most polluting in terms of CO2 gas. And we're going the opposite direction. We're not going that way at all. That's impossible now. And even then, what does the last person die of? There will be penguins. Even in the worst possible scenarios, year 2100, there'll be still be plenty of penguins in Antarctica. If it's cold enough for penguins, how is it too hot for humans? It literally doesn't make sense. And then this is Dr. Tamsin Edwards, who is a climate scientist, works on the IPCC reports, and she told one of the Extinction Rebellion, he's a philosopher called Rupert, who goes around telling children, he goes and talks to children in schools saying they're going to die of climate change. And he's a philosopher, he doesn't know anything about climate science. And this climate scientist is telling him that what he says is wrong. And it deflects from the real issues, that it's poor people who are most affected. If anyone is going to die of climate change, it's mainly poor people, because they don't adapt properly, because they don't have the money to adapt. And the wealthy people who can adapt are not going to die of climate change. And so, and the poor people, then it's mainly if they don't get enough help from the wealthy countries. And we do have this Green Climate Fund, so this is actually being funded much better, so the people in the weaker economies are much more protected than they would have been if we weren't funding this Green Climate Fund to help with the transition. Now, we are not going to die of heat. Humans are heat adapted. We are one of the very few animals that can cool ourselves using sweating. The only other ones that can do that are hippos and horses of the mammals, and monkeys and apes. And the other ones use panting, and that's much harder. So, for instance, I've been out scything in the fields in hot weather in the summer in Scotland. I mean, it's not that hot, it's only probably about 20 degrees centigrade or something, but still I was kept keep cool by sweating. And if I was a lion or something, I wouldn't be able to do that. I wouldn't be able to work for hours on end, or even for an hour. When it's too hot, I would just be sitting panting in the shade, and then doing short runs to try and catch things. So human beings are much more better adapted to heat than mammals are, than most mammals are. And if you look at what's actually happening, then we are actually, most people, this is a diagram, this is the most thorough study to date. Very, very thorough study, actually set up specifically to look at what deaths there are from heat and what deaths there are from cold, and very careful looking from 2000 to 2019, and very large population study. They find far more people die of cold than they die of heat. Even in Australia, many more people die of cold than die of heat. You may not realise it, but there are cold regions in Australia. They have ski resorts there, and some parts up in the mountains and in the far south, some parts of Australia are very cold. And even though most of it is hot and desert, very few people in Australia die of heat. And these are all preventable deaths, just to be made clear. the people who die of cold wouldn't have died of cold if they kept themselves warm. If you like warming, wearing good clothes, and lots of the deaths, for instance, of cold, are people just don't keep themselves warm enough in winter, and some of them, for people, if you fall into cold sea in cold weather, you'll die. And they actually find that through to 2 degrees centigrade, we actually have fewer. We have some studies suggest that through to 2 degrees centigrade, the deaths due to temperature extremes will go down, because although there are increased deaths from heat, there are reduced deaths from cold. And some say it may slightly increase, some say it may slightly decrease, nobody knows. It's only beyond 2 degrees centigrade you start to get studies saying that there may be more deaths from extreme temperatures than there are now. And these are all preventable deaths, so if people are very careful about heat waves and very careful about cold, we can reduce these numbers. And now, another thing people worry about is about the sea level rising. So, first of all, I think some people think in terms of it being a bit like Noah's flood, if you're biblical. It is absolutely impossible. Though we have increased flooding from the rain in a warmer world because there's more water in the atmosphere, and then we also have the sea rising because of sea level rise. But when sea level rise, it doesn't go uphill. This looks at the Statue of Liberty, and I don't know how clear it is from this diagram, but even on the 1.8 degrees C path, we're headed for 2 degrees centigrade with optimistic optimistic pledges. Some say above, with optimistic targets, we are already headed for 2 degrees centigrade, and we are 3 degrees centigrade is just about impossible now. I'll explain in a separate video why that is. And it looks very well below 2 degrees C is well within reach. So this is well within reach, the 1.8 C or less than that. At 1.8 C, by the year 2150, the sea will just start to lap onto the grassy patch at the bottom of the Statue of Liberty. There's a seawall protecting it that's 3 meters high, and by the year 2150, the sea may just start to lap onto that, and it won't if we manage to stay below 1.5 degrees C. So when you see these videos of the Statue of Liberty covered in sea up to there, that's impossible. Even centuries, can't even get up to here, even many centuries in the future. So, and then the many cities, the cities in the world like New York is indeed at risk of flooding because of sea level rise, but it's easily protected by sea walls. Look at the Netherlands, they're several meters below sea level, and all our cities around the world, just about all of them, can be protected by sea walls, just like this sea wall at the bottom of the Statue of Liberty, 3 meters high. That's not a very high sea wall. So if you had a sea wall that high around New York, then the sea's not going to go over it even by 2150. So it's not difficult, and then that's slightly expensive to build a wall 3 meters high all the way around the city, but it's not that expensive compared to the other expenses in running a city. So it's not going to be difficult for the cities around the world, even in weaker economies, to protect themselves with sea walls, even through to 2150 with the very worst bad luck. And the sea is not going to rise up and cover all the land like in Noah's flood. It's impossible. And then the flooding from rain falling, then there are many things I can talk about in a separate video. There are many things we can do about that too. It's basically about making sure that the rain, because it comes down rivers, that it can soak away into places where it's harmless. I used to live in Oxford, and we had these huge floodplains, and when we had a lot of rain, then they diverted the river into these floodplains, and they would fill up with water, and very little would get into the city, and only flood the very lowest parts in the cities. And yet, if you looked around in the middle when there was lots of rain, and you look at the floods, you just see the fields for miles along the river, and quite a long way away from the river, were just full of water. So you do things like that. You slow it down, and then when you're building new houses, make sure the new houses are protected. That they're raised up above the sea, the water, the flooding level, or they're set back from the river. And so people are doing these things. And again, the water flowing down the river is not going to go up hills, it's not going to flood hills, it's not going over the tops of hills, it's not even going to flood above our house. It is raised maybe a couple of metres, whatever the flood level is that you can get in the worst cases. So there's no way that we're faced with a future where people will die because all the land is covered in water. And the people will sometimes talk and say, well look, there are so many million people in cities and they're all going to die. They're not going to die. They'll either protect themselves, or in the very worst case they move. But they're not going to need to move, not in most cities. About the only city where people are going to have to move if we have very high levels of sea level, like in the year 2150, then people may move out of the Florida Keys, they may move out of the lowest lying parts of Miami. There's a possibility with high levels of sea level rise, and just to explain, this 1.8 metres by 2150 is not the expected sea level rise. This is if you have really bad luck. That's if you're on the 1.8 degrees C path and everything goes as bad as possible. So if the ice in Greenland melts at the very fast it possibly could, the ice in the Western Antarctic melts as fast as possible, way above what we're expecting, at the very high end of what's possible. In that very worst case, then a 3 metre high wall will protect you. But except in Miami, where the ground rock is limestone, which is porous, so you can't use a seawall. And it's the same with the coral atolls. The coral is porous, sea goes through it. So there's no way to protect yourself from sea level rise except by building up. If you live in a place like Miami, or if you live in a coral atoll in the Pacific. So that's why in the coral atolls, even though the sea doesn't rise, the sea rises much higher in New York than it rises in the coral atolls in the Pacific, but they can't protect themselves with seawalls. So, and they are very, very low-lying atolls. So the only solution they have there, and they are actually doing this, is to build up. So they dredge in their harbours and things. You dredge up your harbours and more space for ships to go in, and then you build an island which is a couple of metres high. And then you move people onto that island, and then they will be safe from sea level rise, even at high seas. And that is the only thing you can do. And so they may do that in Miami. And it's only the lowest, the low level, the very lowest houses, the houses that already have the sea practically lapping in their streets anyway. Those are the ones that are at risk in Florida. And then if the sea rises a bit more, then the sea will start pouring into those houses, and it's very difficult to stop it, though there are various ways to slow it down. And even then, it's at high tide that you are at risk in a storm surge in Miami. So it's only for a few hours of the day on particular worst possible high tides, only a few times a decade or a few times per year in the worst times. And then what they try to do in Florida is they slow down the sea level rise. So they slow down the sea rising in the city. So the sea rise, so if you have a bit of a seawall, you can slow it down a bit. If you have, and then you have like places that you can divert the water into, just like with the flooding I talked about in Oxford. We have these floodplains. So you have basically the same idea with Miami, that as the sea level rises, they try and divert the rising sea into these various places where it's safe to flood, and try to avoid and get it to avoid cities. And you can't do that much for the sea. I mean, there's so much sea. You're not if it's just you can't do so much for that. But if it's just talking about a surge during a storm, you can do it. And you can stop quite a lot of the surge during a storm from getting into the worst places. And then as the tide goes down, the storm goes away, then the sea drains out again. So there are things they can do even in Miami. The other thing they can do is they can sacrifice the bottom floors of these buildings. Anyway, so there certainly are problems, but these, even in the worst case, the people in Miami aren't going to die of this. It's just they're going to have the ground floors of their houses get flooded. And it's going to be a big nuisance, and if necessary, they may have to move out of Miami. This is not an extinction event. So, and it's not a collapse of society event either. The only way it's a sort of collapse of society is that it's just possible that some people living in Miami may have to move to other places, and in the very worst case, and some of the villages along the coastline where it's just not economic to build a seawall or to do all these measures to stop it, then some of those people have already had to move. So locally you could say, oh, it's the collapse of the society of the village because the people in the village had to move to another place. That's the only sort of collapse of society we have going into the future with climate change. And if you are in a place that is very hard to adapt because you're not getting much funding from the Green Climate Fund, you haven't got much funding yourself, then you might migrate. And in some cases, even with agriculture, when it gets very dry, there's irrigation in the deserts. We can desalinate the seawater. Most of the droughts that we get in a warming world are in summer, and you have higher rain in winter. So if you can capture some of the winter rain and store it through to the summer, then that deals with a lot of the drought problems that most people have in a warming world. That's an example of adaptation, and India is doing that, for instance. India is predicted to have, it's got more water flowing down the streams because of the melting glaciers, at least for a few decades, down the rivers, and it's got dry seasons, but it's got wet seasons. So the aim in India is to do a lot more storage of water from the wettest times of the year, and then in the drier times to use agriculture. Drip-fed agriculture means using water much more efficiently. And India is actually boosting its crops as it gets drier because it's using lots of methods to increase the crops. Like, for instance, now they use dwarf wheat, which grows faster, and at the end of the monsoon season they can grow a second crop of pulses, so they get 2 crops. We used to have 1. And through to 1.5 degrees C, indeed, depending how much we adapt through to 2 degrees C, we can expect to actually get better crop yields in a warming world. Because of the CO2 fertilization, because there's an increase of the growing season in higher latitudes, and then it all depends on how well countries adapt to the droughts and the dry seasons. And if you look at Africa, then Africa has 1 billion people in a much larger place. Africa has about the same population as China and as India, and yet those are much smaller countries. Most of the population growth is in Africa, and as it warms, then if Africa can manage anything like the efficiency of growing food that China has, or India has, or the United States, then it will easily be able to grow food for all the new people in Africa. Most places in the world, the population is actually steady or falling. Africa is the only place where it's rising, and the only continent where it's rising significantly, and if it will, how fast it rises in Africa depends on how quickly they manage to improve their economies, because countries with advanced economies have lower birth rates, and if there is less death of, if there's less infant mortality, if there is greater education for women, including women going to university, if there is equal job opportunity, and generally if there's greater prosperity, you have a much lower number of children per woman. So we're already seeing that. For instance, in South Korea, which is a very wealthy country, then they have amongst the lowest fertility rates in the world, much less than replacement. And Japan also has very low fertility rate. And it's not because the children they can't bring up their children, it's because they have so much prosperity that parents don't feel they need to have lots of children in order to look after them when they die, when they get old, and or in order to make sure that some of their children survive, which is the problem in Africa, that so many children get very sick or die, and the small farmers in Africa, they don't have a retirement fund, and they are dependent on having their children being able to look after their land when they get old and feeble. And if most of the children are dying or get very sick and need to be looked after by other people, then they need to have lots of children, so that when they get old, then there'll be someone to look after them. And so that's why Africa has quite a strong population growth rate, and this is already stabilising, and the big question really is, when will the population rise peak in Africa? But even if they end up with 4 times the current population, even then Africa can easily feed everyone by revolutionising its agriculture and bringing it up to the standard of this agriculture of India, China and the United States. And it's missed the Green Revolution, which is what made it possible for other countries to grow so much more food from so much less area. And so this needs to be looked carefully at African crops like cassava. How do you manage to grow cassava which much higher yields than they have today? And so there's sometimes some of it is just existing knowledge because it's crops already grown in other countries but just not grown very efficiently in Africa. So now I look at, so that's the background, and then this is some of the junk scientists who say that that civilization is going to collapse and we're all going to die. So that's Jem Bedell, the Extinction Rebellion, and Andrew Neil one of the Extinction Rebellion spokespeople talked to Andrew Neil, and in this video he just keeps asking her, where in the IPCC reports it say that billions will die, and she had no answer to it. So the Extinction Rebellion, typically they haven't read the IPCC reports, and he had, well, he'd looked at least at the summary of policymakers or something, and he just kept asking her this question, and she had no answer, because they don't have the answer, because it's not true. And this is Dunlop and Spratt, and they keep predicting collapse of civilization, and even Michael Mann, who himself is a very activist, called overblown rhetoric, exaggeration, unsupportable doomsday framing. I'm glad to see Michael Mann has began to talk in a more positive framing way recently, so that's a good thing. Talking about all the positives. So these are businessmen. These people aren't climate scientists. This is a couple of businessmen and then a forward by an admiral, and they know nothing about climate science. They were going by clickbait journalist stories that they've read, which are not true. And then a lot of people go by are impressed by Sam Karana's Arctic News blog, because it goes right to the top of Google searches. It's no wonder that people think it must be reliable, But Google is not reliable. Google just puts things on the top if lots of people click on it and link to it, not because it's true. And this article news is absolutely absurd. He uses quadratic. You know what quadratic looks? Do you know what quadratic looks like? Do I see it on? I don't think you can see my mouse, sadly. Let's see if I can draw it. You know, quadratic like that. Quadratic goes like that, you know? Like a U shape. That's where quadratic goes. It comes down from infinity and then it goes up to infinity with positive numbers. And this Samkarana chap, he fits a quadratic to our current temperatures or to sea level rise or whatever it is he wants to look at. And this naturally projects it going up to infinity in the future. But he never goes back into the past. If he did, he would show whatever it is he's fitting it to as coming down from infinity in the past. It's totally absurd. And then to make it seem more complicated, he fits other polynomials, like a cubic or a quartic or something. All polynomials go up to infinity in the future or go down to infinity in the future, come down from infinity in the past, or go up from minus infinity in the past. So all his projections either come down from positive infinity in the past, or they come up from negative infinity in the past. And then Neil McPherson, so that's obviously not reliable, not a sensible way to project into the future. And Guy McPherson, he is a climate junk scientist, and he does the same. He actually quotes Samkarana and his absurd polynomial approximations. So that shows he has no discrimination. He doesn't even check things that he cites, or if he does, then he's as daft as Samkarana. It's hard to know which it is. He's obviously reliable in his own particular field, but he's way outside his field here, and he's just junk scientist. And then this is David Wallace Wells, and he talks about uninhabitable Earth, and again all the time he's just a journalist. He says himself that he only first became interested in this a few years ago, and since then he's basically done a scrapbook of all the worst journalist stories, and he made it into a book. And he's got no credentials whatsoever on this topic. Just a journalist. So all of this is junk science. Just ignore all this. It's just junk science and nonsense. And just say Jem Bendel, he is a social scientist. Now social science has a huge amount to offer for climate change. And it was done properly in the IPBES report in 2019. So they looked at how we can move forward to actually take the measures that are needed to reduce the effects of climate change and reduce the impacts widely throughout the world. And to do that, they involved social scientists, and social scientists there looked at how it would work politically, how it would work in communities, the interaction between the communities and their local government and indigenous people, and that's the science. And what kind of measures that the politicians could take. The IPCC don't do that. They just present the science. But IPBES, they look at that as well. So they looked at the sociology of how we actually get these changes happening in the real world based on the science. And this found that sociologically it is totally doable, it is beneficial, and people can come to understand that it's beneficial to do this. And they said that the key thing is empowering local communities so they find their own local solutions. And they talked about many things on a sociological basis, based on analysing what actually works in the world, what is working so far, and how people behave in response to various incentives, and how they behave in response to regulations and initiatives and so on, and how it's very important for them to own their own solutions and to look, and they have knowledge of local conditions. And so they looked at how sociologically it works best if you empower local communities and they actually know better, a better understanding of how to fix their own local situations to achieve the climate objectives. So, and that the experts can also learn from local communities. So social scientists looked at all that, and so it's very, very useful. It's a science. It's not a fuzzy thing. It's not like philosophy. Social science is a science, and I think it's widely called a kind of hard science, really. But they talk about physics as somehow being different, but there's quite a lot. It is a scientific field of study, and this is actually hugely beneficial in helping us to make the right decisions as for governments and for local communities and indigenous people to make the right decisions politically and socially as well as scientifically. Type of belief, I should fix that. So, and so as I've just explained here, many things you find, I may have a look at this, talk about this in a separate video. There are many things that you find as in the mainstream press about climate change that are just wrong. And others are people doing extreme negative framing. I'll talk about this maybe in a separate thing. So the main thing is to listen to the scientists and there are also a huge amount you can do as an individual. So there's an awful lot here. I don't think I'll summarize all that here. I don't want this to be too long. Just have a read of that. I'll put that in the video description. And so I'll stop this recording now. And so I hope this was helpful. And I do this mainly to help people get very scared. So far, our Facebook group Doomsday Debunked, and we greatly welcome anybody who wants to join the group who can help with fact checking like this and help explain to people what the scientists really say and what the real risks are. And if you are scared, then you're very welcome to join our group and to get help on things like this as well. And it's a community, and do check the rules at the head of the group. That is how we manage to work as a group. That's how we manage to work. So, thanks for interest in listening, and I'll now stop this and upload it. And do join and subscribe and like this channel to find more videos like this.